Okay, last day on factoring, and then we're going to take these properties of factoring and we're going to apply it to word problems. But today we're going to look at why we're factoring. So just real quick, and we haven't looked at the shape of these graphs yet, when we have a polynomial, a quadratic polynomial for that matter, it is a curve like this. And this curve hits the y-axis, and it also hits the x-axis, and it hits the x-axis twice. And these are called the x-intercepts. And we know that when a point hits the x-axis, we have a number for x, and y is always 0. So we're going to look at the polynomial today and figure out, okay, what is this x-intercept? How can we use the properties of factoring to find out what these are before we even graph it? And so let's go ahead and get started, and we are going to apply the properties of factoring that we learned on day 1 and day 2. So let's go ahead and get started. Okay, so why do we factor? I talked briefly about the shape of a quadratic function, and we factor to find the x-intercepts of the quadratic function. And we also call that the zeros. So we want to know when y equals 0 on that y-axis, what are our x values equal to? So we're going to use something called the zero product property. To find the x-intercepts of the quadratic function. So we're going to let all our quadratic functions equal 0. So remember that y equals 0 for an x-intercept, so we'll set our quadratic expressions equal to 0. And we're going to use that to find those x-intercepts. Then we'll factor and solve to get those x-intercepts or those solutions. So the zero product property states that at least one of the factors must be 0. What that means is if I have x times y, well, let's say this, if I have x times 2x equals 0. For this to equal 0, either this x has to equal 0 or this x has to equal 0. So this simple statement gives us powerful results, which is used most often with equations involving products of binomials. So let's look at this example here. So really what we have is a y equals equation. So this is the same as saying y equals x plus 5 times 2x minus 6. And we want to know when y is 0, what is x equal to? That's what we're trying to figure out. So we know two things. The property says that either this has to equal 0 or this has to equal 0. So whatever I put in for x in the first set of parentheses, I have to have that equal 0, and what I put in for x in the second set of the parentheses, that also has to equal 0. So if we look at x plus 5 equals 0, if we solve for x, we get x equals negative 5. And as an x-intercept, that's the point negative 5 equals 0. Because we're trying to find out when y equals 0, what is x equal to. If I do the second one, 2x minus 6 equals 0, then I get 2x. If I solve for x, I get 2x equals 6 and x equals 3. And as a ordered pair, that would be the point 30. So if I were to graph this quadratic function, this quadratic function would intercept the x-axis at those 2 points. So real quick, let me give you a visual. So here is my x-axis. This is my parabola. This, not drawn to scale, would be the point negative 5, and this would be the point positive 3. It's where this graph crosses the x-axis. So in example 2, we're going to do the same thing, but example 2, we just have to set it up a little differently. Not too much. So we need to get this equation equal to 0. So I'm just going to subtract 5 from each side, and I'll get x squared plus 4x minus 5 equals 0. So again, when y is 0, we're trying to figure out what is x equal to. So if we factor this, we need factor pairs of negative 5 that add up to 4, and we get x plus 5 and x minus 1 equals 0. So we have two options. X plus 5 equals 0, which means that x is going to be equal to negative 5, and that as my x-intercept would be negative 5, 0. Our other option is x minus 1 equals 0, and so that means that x equals positive 1, and as an ordered pair, it's 1, 0. So again, if we were to graph this quadratic function, I'll make a little graph over here. If we were to graph this quadratic function, it would pass through at negative 5 and positive 1 on the x-axis. So why do we want to factor this? Well, this factoring can help us solve word problems. So if we have the sum of an integer and its square is 72, what is the integer? So how can we use this zero product property to help us solve this problem? So we're going to let x represent the integer. I don't know what it is, but we're going to figure it out. So then that means that x squared represents the integer squared. So from our equation, we know that the sum of an integer and its square is 72. So the sum of an integer and its square is 72. So we want to get this equal to 0, so we just have to subtract 72 from each side, and we get x plus x squared minus 72 equals 0. So again, when y equals 0, we're trying to figure out what x is equal to. So if we factor this, we need factor pairs of negative 72. Well, let's rearrange that in standard form first. In standard form, it should be x squared plus x equals 72. So let's rewrite that. It's x squared plus x minus 72 equals 0. So we'll still need factor pairs of 72 that add up to 1. And it's a negative 72, so that would be x plus 9 and x minus 8. One of these two binomials has to equal 0. So that would mean that if x plus 9 equals 0, then x is equal to negative 9. And if x minus 8 equals 0, that means that x is equal to 8. So in a complete sentences, the integer we can use negative 9 or positive 8. Okay, let's take a look at the last word problem. A rectangle has dimensions that are binomial factors of 3x squared plus 22x plus 24. So the length and the width are the factors of 3x squared plus 22x plus 24. So we need to factor 3x squared plus 22x plus 24. And keep in mind from yesterday's notes, first term goes down here, last term goes over here. We're going to multiply 3 and 24, and we get 72x squared. So now we are looking for factors of 72 that add up to 22. And factors of 72 that add up to 22 are 4 and 18. So this is going to be plus 4x plus 18x. So we are going to factor this binomial and factor this binomial. So out of 3x squared plus 4x, we can factor out an x, and we get 3x plus 4. And from 18x and 24, we can factor out a 6, and we also get 3x plus 4. So our first factor pair is 3x plus 4, and our second factor pair is x plus 6. So the length and the width of the rectangle, the dimensions of the rectangle, are 3x plus 4 and x plus 6. So if we have a rectangle with side lengths of 3x plus 4 and x plus 6, how do we find the perimeter? Well, perimeter is to add. So perimeter of a rectangle is 2 times the length plus 2 times the width. So that's 2 times 3x plus 4 plus 2 times x plus 6. And it doesn't matter which one is the length and which one is the width. And we multiply those, we get 6x plus 8 equals, plus 2x plus 12. And so the perimeter, when we combine like terms, is 8x plus 20. Okay, now it's your turn. In multiple choice question number 1, it's asking you what are the zeros, and what it's asking you is what are the x-intercepts. So when y equals 0, what is x equal to? Number 2, the width of a rectangle is 6 inches less than twice the width. 6 inches less than twice its length. Find the dimensions of a rectangle if its area is 108 square inches. Write an equation for width and length, then solve. Be sure to think about what answer makes sense, and then check your work. And keep in mind, we can't have negative lengths of a rectangle. So if you get a negative number for your x, you want to throw that one out and you want to use the positive one. Please be sure to put your answer choices in the Google form, and if you have any questions, put those in the Google form as well.